So welcome to this tutorial, which is going to look at one of the classic rigid body simulations, which is a ball crashing into a brick wall. So first of all, we need to set up our brick wall, and I'm going to lay down a geometry container here at the scene level, and I'm going to call it brick wall. I'm going to dive inside. We get a file node inside automatically. I'm going to delete that, and I'm going to lay down a box. This is going to be our brick, so I will call it brick, and I'm going to make the x and y dimensions 1/2 and the length 1. Now we're also going to have half bricks at the end of our line of bricks in order to make the alternating rows line up, as we'll see in a minute. So I need to create a brick which is half as long as this one. And I can do that using what's called a reference copy. A reference copy creates a copy of the node, but all of the parameters are referenced back to the parameters in the original. So in this case, if we enlarge it, we can see that the x part of the size parameter is referring back. This is what this ch channel function does. It takes the value from the parameter referenced in here. It's referring back to something which is one level up in the node hierarchy, is called brick, and is called size x. So one level up in the node hierarchy is this level here, and then we have brick, and if we hover over the label here, we can see that these three parameters are called size x, size y, and size z. So this is looking at this parameter here. Now in fact, I don't want it to be identical. I want the dimension in the z direction to be half as long. So I can change the formula. And now if I increase this on the original brick, the new brick changes. And I'm going to call this half brick. So the next thing to do is to create some points onto which we can copy these bricks. And I'm going to do that using a line SOP. And a line SOP creates a line, obviously. We can't see it at the moment because it's being hidden by these axes here at the center, so I'm going to switch off the grid and then go into display options by hitting the D key and turn off origin gnomon. Now we can see it better. Now our line is going to need to be spaced so that these bricks fit on it perfectly. And to do that, I'm going to take a reference to this parameter here, which is the length of our brick, and I'm going to copy the parameter, and then in this distance field here I'm going to paste not the parameter but a relative reference to the parameter. Now we might think that what we need is a line which is the same length as the length of the brick times the number of points. Now the points are in a field called points, so if I put a reference here picking up that value, then we should get a line that's the right length. I'm going to make the line in the z direction, and I'm going to see what that looks like by laying down a copy SOP. Now the copy has two functions, and we're going to be using both of them in this network, but what we're going to use it for this time is to copy geometry onto the points of other geometry. As you can see, the copy SOP has two inputs. We can middle click on them to find out what they are. Template to copy to. So let's put our line into there. And then the brick is what we're going to copy onto it. So let's put that in the other. Now that's not what we expected. We're getting a big gap in between the two. And that's because, in fact, we need a line that's multiplied by the points value minus 1. And now if we increase the points value, we get a line of bricks perfectly stacked together. Let's make this 11 bricks long. So that's a single line of bricks. What do we do to create a stack? Well, we can use another copy sop, and I'm going to insert it here. This time we're going to use the copy sop to create a group of copies, a set of copies of the geometry coming into the first input. So this is the second way that a copy sop can be used. And as we can see here, what we can do is, for each copy, move it a little bit up. And the amount we need to move it is, of course, the height of the brick. So if I copy this parameter and paste it in here, paste a reference to it, then we should find that when we increase this value, we're getting a nice stack of bricks. This is all very well, but what we want is for these bricks to be offset, each alternate row to be offset. And to do that, I need to use a group geometry sop. Now each of these rows, we've got 7 of them at the moment, is a primitive. We can see we've got 7 primitives. So what we've got is 7 lines. So I want to group primitives, and I'm going to call this alternate rows. And if I put the value $OS in here, the group name will be the same, alternate rows. And I'm going to group this using a range. So what this does is select every one of 2 rows. So every alternate row is being selected. This happens to be the default when you group by range, but obviously you can change this to select 1 out of every 3 or whatever. So when I group by alternate rows, what I'm going to do with it is lay down a transform sop, and I'm going to apply this only to the alternate rows. And now I can click on the viewport and create and see the movement handle. And as you can see, I can now move every alternate row. And I want to offset them by half a brick's length. So again, we're going to need the brick length here. I'm going to copy the parameter, and into this field here, I'm going to paste a relative reference. Let's enlarge this because it's half a brick, so I need to take that length and multiply it by 0.5. So now we have our bricks nicely offset, but there are holes in each of these places. How are we going to fill those? We'll look at the answer to that in the second part of this tutorial.